All right, welcome back everybody. This is our second video on section 6.7 of AP Calculus, the Fundamental Theorem of Calculus and Definite Integrals. And in this video, we're just going to pick up right where we left off and do a bunch of examples related to the Fundamental Theorem of Calculus Part 2 and how we can use that to help us find the value of definite integrals and solve problems related to definite integrals algebraically. All right, let's pick up with example 4. If capital F of x is an antiderivative of lowercase f of x, and capital F of 3 equals negative 2, then what is an expression that is equal to f of 8? Okay, so from the fundamental theorem of calculus, we know that if f of x is an antiderivative of lowercase f of x, then the integral from a to b of f of x dx is equal to capital F of A minus capital F of B. So we're told in this problem that f of 3 equals negative 2, and we want an expression for f of 8. So I'm going to use those as my limits of integration here. The integral from 3 to 8 of lowercase f of x dx is equal to capital F of 8 minus capital F of 3. And since we want an expression that's equal to capital F of 8, I'm going to isolate that by itself. Capital F of 8 is equal to, and it's equal to the integral from 3 to 8 of f of x dx plus f of 3. And we're told that f of 3 is negative 2. So I probably would write this as capital F of 8 equals negative 2 plus the integral from 3 to 8 of f of x dx. And believe it or not, this form is something that we are going to use a whole lot in problem solving with integrals later on in the course. All right, let's go on to the next example. Example 5, selected values of the twice differentiable function f and its derivative f prime are given in the table below. What's the value of the integral from 0 to 4 of f prime of x dx? So the integral from 0 to 4 of f prime of x dx is equal to the antiderivative of f prime of x. Well, f prime of x is just the derivative of f of x, so this is going to be equal to f of x evaluated from 0 to 4, so it's going to be f of 4 minus f of 0. And those values we can just pull off of the table. F of 4 is 7. F of 0 is negative 5. And therefore the value of this is 12. There's the end of example 5. Example 6. Let f be a differentiable function such that f of 2 equals 5.128 and f prime of x equals the cosine of the natural logarithm of x. What's the value of f of 5? So we know, we're talking about the value of f of 5, we know the value of f of 2. The relationship that we know is that the integral from 2 to 5 of f prime of x is equal to f of 5 minus f of 2. We're trying to find the value of f of 5. So if I isolate f of 5 by itself, this is equal to f of 2 plus the integral from 2 to 5 of f prime of x. I need my dx in there. And so we know the value of f of 2 is 5.128. And we know that f prime of x is the cosine of the natural logarithm of x. Now at this stage, we don't know what the integral of cosine of the natural logarithm of x is. That's not some, easy to find antiderivative for us. So I'm going to use this setup, and I'm going to go ahead and use the numerical integral feature on my calculator to find the value of f of 5. And it's going to be 5.128 plus the integral of the cosine of the natural log of x with respect to x from 2 to 5. And we get 6.121 as the value of f of 5. All right, one final example in this lesson from a graph. The graph of G consists of line segments and a semicircle as shown in the diagram below. What's the value of the integral from -4 to 4 of g prime of x dx? Again, we're utilizing the fact that we know that the integral from -4 to 4 of g prime of x, all we need to do in order to get that is we need to take the antiderivative, which the antiderivative of g prime is just g, and we're going to evaluate that from -4 to 4. So this is going to be equal to g of 4 minus g of -4. And since this is a graph of g, that means I can just read the points directly off of there. When x is 4, y is -1. And when x is -4, y is 2. And so we end up with the value of this integral being -3. All right, that's our last example for this lesson. Takes us to the end of this video, so we're going to go ahead and sign off right now. Have a great rest of your day. See you next time when we come back for section 6.8. 6.8, which is finding antiderivatives and indefinite integrals, the basic rules and notation. We're going to get into the indefinite integral next. All right, see you everybody. Have a great rest of your day, and enjoy yourself.